Sorry, yes. So quiz corrections, test corrections, always due the day of the next test. Is this somebody's shirt? What is this? It's a pillowcase. I don't know. Spare all expenses. So a real quick, did we finish that worksheet? Let's see. Can't remember now if I even have copies. Here we go. No, Jeff, that's not it. There it is. Yes, I think. The one about the kids and they're retiring. It looks like we almost finished it. Yeah, okay. Let's see if I can get you guys to remember with me this worksheet. So this is the one that on one side had 500 adults asked how many email addresses they had. Remember this? And then the other side was about the kids retiring, thinking that they were.
Yeah, I don't know if that was us.
It's been a week, I understand, but I have video evidence that we did this. Let me see how many more copies do I have. I'm pretty sure you guys were here.
I don't think so. Hold on.
This is my last one. So.
Is this it?
That's it.
Okay, when
Did
you
get
want to
that
give
right?
this to somebody else?
I do. Oh, no, he's got it. Okay. All right. I know. I agree. All right. We're all gonna make it. We're all gonna make it. I think a lot of us are tired. And part of that is because of what I've made you do. So I'm just going to continue that path. Oh, come on, Jeff. Input. Now. You guys see that? Okay, so we actually, believe it or not, somebody, can you click off the one that says inboard and whiteboard? Let's see what that does. Yeah, I think pick one of those. Let's see what it does. That's good. You guys can sort of. All right. So that's the side that's all worked out. We did this in the calculator. Okay, is this coming back?
Yeah.
All right, so remember we did exactly what this says. We put that in L1, we put that in L2. X times P of X would be all the stuff in L1 times all the stuff in L2. And then I'll give you one way to get X squared P of X. Right? X times X P of X is X squared P of X. And then we added them all up. We did the sum thing in the lists. And we got those numbers. All right, so one kind of conceptual thing that seems really silly is that in order to be valid, we all know this already, they have to add up to be 1, all the probabilities, right? We know this. Or close to 1, yes? Because you could round, and you just happen to round up more than down, or down more than up. So it could be close to 1. But also, they all have to be between 0 and 1. That only makes sense, right? Can't have a probability more than 1. You have probably a negative probability, no matter how bad you feel about the chances. It can only at worst be 0 chance. So then we did at least 25. You could just add up all these probabilities, but the shorter way to do it is just 1 minus the one that we left out. That's that idea of 1 minus the opposite. Okay.
Wait, why is it 1 minus 0.04?
So I really want this to make all the sense in the world. I hate that I don't have a laser anymore. I used to have a laser that I could just do this with, but Where in this chart is at least 25?
25.
On the second one.
Bam, all this stuff, right? So you could add all of these up. Now, please let this just make all the frickin' sense in the world. The answer would be all these added. What is all of these added? All of them.
1.
So what must 1 minus this one be? Doesn't it have to be all these?
Okay.
Bam, that's what 1 minus shit means. 1 minus the thing I left out equals the other shit.
Or you could just add all of them up.
Or you can just add them all of them up. However you're feeling that day. I love it. Does that make any, at least a couple of you guys, it seems to make more sense. And of course, we're all like remembering that this actually happened. It wasn't some collective dream. Okay. This could be right now a collective dream. We're not going to make this a philosophy class. All right. Do we all exist? Do I exist? Do my thoughts actually exist? Are they going to get me when I go to sleep? All right, stop. Now, here's the new shit. This should sound very familiar. We've done this kind of thing before. There's going to be a little twist to it, though. Doesn't this sound familiar if you read through this? Put the mean in the middle. I want to know what percentage is within one step. Okay, so what was the mean? I need to
45.89.
give me a pen. There it is. No. All right. Yeah, 45, that sounds about right. What was it? 45.89, I like it. So I'm going to put that right in the middle. There's the mean. Then I want to go up and down 1 standard deviation. Somebody help me out. If I go up one of these, where do I end up? Anybody gonna help me? Is that right?
Give me 4 seconds.
Oh, I'm sorry. It's weird. It sounded like it came from somewhere else. Give me 4 seconds. Got it?
Yeah.
Is this right?
63 point. Oh yeah, you already did it.
I did.
Oh, okay.
And then if you subtract, $28.4 something? 26, thank you. Okay, now, do you guys, anybody agree with me? Do you remember doing this kind of problem? That problem on the test, right? Did you get and then I asked you part B was, put the mean in the middle. But now I want to know what percentage is within 1 standard deviation of the mean. Right? If it's normal, there should be 68% in there, remember that? Okay? I like it. I got my shirt on, yay. So, the difference here is, can somebody tell me which data points I just caught? Did I catch the 21s in here?
No.
No, because they're down here. Did I catch the 25s? No. You guys see that?
Yeah.
There's always somebody that doesn't understand what I'm saying when I'm saying this, but it's just, what did I catch? I didn't catch those because they're out there. What about the 40s?
Yeah.
Hell yeah. They're right there. I caught those. What about the 50s?
Yeah.
Yeah. What about the 65s?
No.
Hell no. And definitely not the poor kid that thinks he's going to work to 100, which you never know. Okay. So here's the problem. You can't take 40 and 50 and say that's 2 out of however many. That makes no sense in this kind of problem. Because if I caught all the 40s, what percentage of the data is already 40? What percentage of the kids said 40?
23.
I've already caught 23%, and I caught the 50s. So how much more did I catch?
18%.
So what's the total I caught?
41.
Yes. So I caught 41%. So remember what we did before was we said we caught this many data points divided by the total number. Of course we did, because I didn't have any percentages. I had to create my own percentage. Here, I have the percentages, right? So if I catch the 40s, that's already a certain percentage. So you just got to add the percentages up that match with what you caught. So does this look like it would be normally distributed?
No.
No, because this is supposed to be 68%, this is way under that. Okay. Let me stop for a minute. You guys okay? We're all tired. Jeff was too nice and let us out after the quiz, didn't talk any shit, so now it's been a week since we talked about any statistics. Okay. So what about, don't say anything. Think about this. How are you going to figure out, don't say anything, think about it. How many kids believe they'll retire before 65? Answer this question. How many total kids were there in this survey? Do you know?
1,200.
Yeah. How does she know that? Because she can read. Wait. Now, don't say it again. I want to know the percentage of kids that think they'll retire before age 65. I want to know the number of kids. Sorry, I think I just gave something away. I want to know the number of kids that think they will retire before they are 65. So it's a two-step problem. How many kids believe they won't retire until they're 100? Well, what percentage think that?
2%.
2% of these poor kids think they'll be working away until they're 100 years old. Oh my God, right? Okay, for a while they were going there, and then the pandemic happened, and before the recession happened, and our life expectancy sort of stopped going, and so anyway, so now who knows? 2% of how many?
1,200.
1,200, right? Now take a second. You guys do this. How many kids, think they will retire before 65? Don't say anything. Just do it. So, you need two things. You need the total number of kids, well that's 1,200. And then you need to know what percentage of 1,200 would answer the question, well what percentage of the kids think they'll retire before 65?
69%.
Everybody cool with that? 69%. If you add up all the percentages below 65, it's 69%. So 69% of the kids think that way, so 69% of 1,200. And we know that of means multiply. So, whatever the hell that is.
828.
All right. Oh, yeah. I was kind of hoping you weren't needing a copy of this because I don't have any more. No, okay. Maybe I do. Actually, do you need a copy? Yes. All right. These are the kind of questions I like to ask on quizzes and tests and stuff. Right, so this is not bad. I gave you a completely worked out problem. There it is. And we did this one together. Yes. I'm trying to make you sick. All right. Okay. So that is 4-1 is really focused on just the distributions themselves. 4-2, I believe, is where they bring in standard deviation if I can rely on my memory, which is a big if. So now we're going to talk about 4-3. Sebastian, can you help me out again? Can you bring it back up, the lights? Oh, turn that. Oh, you got it? Okay. Cool. All right, so I'll leave you on for now. We had a problem on that, let me see if I remember, yes. On the quiz about the 78.2% of Americans would vote for LGBTQIA candidate. Does everybody know what those letters stand for? I think most of you guys probably know some of those letters anyway.
Yeah.
So, I asked a very specific question in there. So let me do a different kind of problem. Let me do a different problem. Let's say, yeah, let's just do the standard one, Jeff. We know that 11% of Americans are left-handed. Is anybody in here left-handed, out of curiosity? 1, 2, 3? 3. Okay, let's see. 2, 4, 6, 8, 10, 12, 14. 3 divided by 14 is 21%. Huh?
Oh, never mind.
3 divided by 14. Or I guess I'll add me in. 3 15ths will be easy, that's 20%. I didn't count me too. I'm not left-handed, so 20% of students in this class right now are left-handed, which is higher than the
Average.
percent of for everybody, yeah. I like it. Which is, for a small sample, it could be whatever the shit. We could have all been left-handed. All right, anyway, so this is true the last time I looked. And I don't know the last time they tried to measure this, but this is the last one that is known. So about 11% of Americans are left-handed. An old question would be, if I pick 4 Americans randomly, Jeff, what's the probability that the first 3 are right-handed, the last one is left-handed? Okay, so this is an old kind of problem, right? I tell you exactly what each spot is. This is old shit. This is a chapter 3 problem. So I got 4 spots, right? What do I have times in the middle? Why do I put times in the middle?
It's a and problem.
It's a hidden and problem. And hides easily. I want the first one to be right-handed and the second one to be right-handed and so forth. I like it. So somebody else tell me what goes in here. Good, I love it. I want the first 3 to be right-handed, or I should say, let's say this, guys. What does this symbol mean?
No.
L means left-handed, correct? And what does that bar on top mean?
Opposite.
Not left-handed,
Okay.
correct? So that would include people that don't have a left hand, that don't have hands at all, that are ambidextrous, right? They can use both hands. That are neither-handed, they can't do anything with either hand out. Just count, it covers everybody, right? So if there's 11% chance left-handed, there must be an 89% chance not left-handed. And of course the last one, okay, let me make sure you guys, does that feel familiar, or we've done the kind of problem before? Yes? Yes? We did it with the, was it the one, I can't remember now, with the chocolate milk one?
In Brussels sprouts or something.
Yeah, yeah. No, that was an extra little thing. 069. I don't know. 0673. Somebody gonna help me? I don't know. That sounds about right.
0775.
0775? Okay. I feel good about that. I let myself be further off when I'm tired. Now, that's old. That's old shit. Old shit, Jeff. So what about some new shit, Jeff? So now, can somebody tell me, same thing. 11% of Americans are left-handed. We're gonna pick 4 Americans, but now I wanna know what's the probability that exactly one of them is left-handed. What is the difference between those 2 questions? Isn't that a situation where one is left-handed? Yes?
Yeah.
So how is that question very different from that question? Which person was left-handed in this group?
The last.
The last one. the last one had to be the only left-handed one. So now look at this question. I want exactly one person to be left-handed. Do they have to be the last one? How many things could they be? That one person could be the first one, second one. We get it, Jeff? Okay. So let me do this. Guys, I really want you with me. I like it. You all look. You're looking at me. Okay. So exactly one left-handed person. Let me introduce this real quick. I should have done this earlier, but sorry. The probability of left-handed, we're going to call that, which is 0.11, we're going to call that little p. Little p. So little p is the probability of success. And a success could be a rabid squirrel or a dead body. Success is just what we're looking for. It doesn't mean a happy thing. I love you guys. You guys look beat up and beat down. I'm sorry. Okay. So probability of success is just what I'm looking for. I'm looking for left-handed people. Therefore, the probability of success is a left-handed person. Okay. So what's the probability of failure going to be? It'll be non-left-handed, which somebody already figured out for us. 89. And we're going to call that Q. Why not? And this is not my choice. This is what we do. This is what we call it.
So that's consistent every
Consistent,
time it's gonna be
everywhere.
Q? Okay.
Every teacher except the crazy ones. And we're hunting them down. We're going to make a series. It's going to be really boring Netflix series. Okay, now. So let me really state the full English of what's happening. So what's one situation that matches what this is looking for? The first one is left-handed and the others aren't. Or the second one is left-handed and the others aren't. You with me?
Yeah.
Or third one, others aren't. Or fourth one is and the other ones aren't, right? So that would mean, what is the ways to match this? First one is, the last four aren't. Four, Jeff, last three. Or the second one is, and the other three aren't. Or the third one is, and the other three aren't. Or the last one is, and the other three aren't. Okay, let me stop for a minute. So the main difference between this question and that question is, this question, there are more things that match what it is looking for. Because there's more than one way to have one person. It could be the first and second one. Okay, maybe. Okay. So I really, do you guys notice how, let's see, what's this one? This one right here, isn't this that?
Yeah.
Isn't this, does everybody see that? This is that. So this was a very specific question. There is one less left-handed person, but it's not the only way. There's the other three. Okay, stay with me. We're all tired, and this is probably not the most exciting subject in the world, but how do you write mathematically each one of these? Math looks at this shit and says, what is your problem, dude? You wrote the same thing freaking 4 times. What is P times Q times Q times Q? Say again? No. I know, but symbols wise, the symbols, in symbols. What is P times Q? What's a better way to write Q times Q times Q? Q to the, okay, so all of these are PQ to the third power, right? So that's PQ cubed, let's try to say that. I'm gonna try it right now, several times. Plus PQ cubed, plus PQ cubed, plus PQ cubed. Okay, which is how many PQ cubes? How many PQ cubes?
4.
4. Please make me stop saying that. All right, now listen, guys, listen. Look at this and see what makes sense here. How many successes did the problem want me to have?
1.
It wanted me to have 1 success, which means inherently I had to have how many failures?
3.
3, because there's 4 people, yes? So 1 success, 3 failures. This number tells me what? What did that number tell me? Where did it come from?
How many possibilities?
How many ways there is to do that. So tell me real quick, if I would have said exactly one left-handed, but we picked 87 Americans, how would those powers have changed? I want one left-handed person. That would have still been one, but this would have been what?
86.
86. Does that make sense? Got
And
87, and I want one success. I want the rest 86 failures.
And then the 4.
This number would be exceptionally larger. Well, in that case, it would just be 86. But normally it's going to be a lot bigger than you think. All right, so this number is what we're going to need the calculator's help on. This is the first time I'm going to let us use a couple of key punches to get a number. But it's not the answer yet. It's just the part we need right there. So, all right. So I can always figure out. So let's do this. Before I tell you how to get this number, let's first figure out what this is. This will just be 4 times 0.0775, right? Is that cool?
Yeah.
Because one of these was 0.0775, so now I got 4 of them. All right, so whatever the hell that is. Whatever the hell. Man, I need a little caffeine. Come here. Let me make sure. Is that caffeine? Oh yeah, it's good. All right. Okay. Can anybody help me out? What is that? Anybody? Nobody? Is it 0.66? No, it's too big, Jeff. 0.33? What is it?
0.31.
3.1? All right. 0.31 or 31%. Okay. 31% chance to get exactly one left-handed person out of any group of 4 people. I like it. So, let's do this. Same situation, but now, what did I say? There's 15 people in here, right? 15 people. And I'm really sorry, there were 3 left-handed people in here, correct? So let's figure out that probability. That happened. Let's see what the probability was. Is it really freaky? I want to know the probability of exactly 3 left-handed people. Lefties. Is that how you spell lefty? I have no idea. So, do you agree with me? Let me just do this. You can write this in your notes if you want to. Wouldn't this be like this? P, P, P. Q, 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 Q. All right. Maybe the first 3 are left-handed. Or maybe the first 2 are left-handed and the 4th one is left-handed. Or maybe the middle 3 are left-handed. Or maybe the last 3 are left-handed. Or maybe the first one is left-handed and the 3rd one is left-handed and the 7th one is left-handed. Holy shit! All right, we're kind of overselling this. But do you guys want to make that list? Do you understand? Do you start to understand how long that list could be?
Mm-hmm.
You don't understand how long it actually is right now, but you understand it's probably longer than you want to deal with. Can you imagine trying to keep track of that shit? Do you want to? I don't want to. But, so right now, I'm going to put a blank spot where that number would go. Because do we know how long that list is? No. And we don't want to find out, thank you very much, right? So we're going to need some help from the calculator. Does everybody understand? That was easy, because I could see it. That was nice. Oh, this problem was so nice. This one, no. But, can somebody please tell me, what would the powers be?
1.
Wait.
No.
No, wait.
3.
Sorry, Ben. Somebody. I know you know it. Sorry? What would the power be on the P? What does each one of these have?
3.
3 successes. And 12 failures. How did they know it was 12? Because it got how many total people? How many total people? 15 people. People. So if I just knew what this number was, right? I don't know what that number is. if I just knew what this number was, I could then multiply it by 0.11, where'd it go? There it is. The third power, 0.89 to the 12th power. So we need a way to figure out what that number is. And the only way we know how to do it right now is to finish the list, and this is nowhere near done, right? So here's how this works. Just to kind of prime you for the right buttons to push in the calculator. How many total people did we have back on this one?
It was just a mayor, oh wait,
It was just 4, right? I just had 4. And how many of those 4 did I want to end up having be left-handed? 1. So I wanted 4 people, and I wanted to choose one of them to be left-handed at a time. So didn't I do that here? I chose this one, and then I chose this one. So I want there to be a magic couple buttons I could push. That if I tell it 4 people, and I tell it choose one at a time, it'll tell me how big the list would be. That sounds really nice, right? It sounds like something a calculator should just live to do. Because that's what they do, they count shit, right? Okay, so here's how to do it. Anybody need a calculator before I get into it? I see a lot of motion and not many calculators. Hopefully, shit, well, I might not have run my calculator. I'm low on liquid. That's another guarantee we're not going to stay a long time. All right, is that everybody? Oh. I did not prepare well at all. My computer's not turned on. It sucks. All right. Oh, that's one good thing. So, come on. Oh wow, that is quick. This is the fastest computer I've run into on this campus. All right. Bump, 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 bump. There we go. Yeah. All right. So if you click 15, then go to math. Go to probability. Did you see this one right here? Don't do National Public Radio. Do NCR. That C stands, it actually stands for something called combinations, but I like to call it choose. So that's basically what it really is. So I got 15 people. I'm going to choose, what was it, 3, right? So let's just see how long that list would be if we finished it out. That's how long the list would be. That list would go on for 450 more entries. You with me? Yeah, no thanks. But now we know what to put here, right? I really want you guys with me. Because we put that 4 there, why? Because there's freaking 4 in the list. So now we have a way to figure out how long any list would be without actually having to create the list. Yay. Yes?
And you put 3 there because you have to find exactly 3?
Yes.
Okay.
I like it. So to do this whole thing, I would do this. I would do, well, you know, let's stay with me. Let's do the whole formula all at one time. 15, choose 3, and then I have to hit the up arrow, the over arrow to get up, right? If you have the newer ones. Times, I got how many successes? I got 3 of them. Times the rest of them. So always, these powers have to add up to be the total number. That's kind of cool. So I got just about a 15% chance. So something just happened. 3 people in here are left-handed. And there was a 15%, just under a 15% chance that that would happen. So was that really kind of surprising? Not really, right? It's not that rare. You guys with me? Where are my left-handed peoples? I'm not saying that you're not surprising and rare people. I'm saying that you guys, if there would have been maybe 8 left-handed people, that probably would have been a very low probability. What would change if I wanted exactly 8? What would be the only things that would change? Instead of 3, I want 8 left-handed people. What would change in the equation?
So it'd be 11 to.
Well, it'd be 15 choose 8. So then I have how many successes? 8. And then how many failures?
7.
7. Because I have 15 total people, right? Let's see. Let's see if the calculator might blow up. Not literally, thankfully, but I'm going to do it the sneaky way. I can just go back and do it like this. This probably takes longer than actually just rewriting the chapter. Probably. Let's see what it does. Oh, look at that. What's that? What does that mean? Has this come up? I think this has come up, right? No? Have we seen this kind of thing yet? It's definitely not 6. Don't say 6. Because that means 610%. Yes? So obviously don't say that. Yes?
You just move the decimal back 5 places.
Good. So this means times 10 to the. I see this and I read it as times 10 to the. So you would move the decimal 1 and then 4 more, so it'll be 4 zeros. That would be unbelievably unlikely, which makes sense. I wouldn't expect more than half of the class to be left-handed if there's only 11% chance to have that a person is left-handed. Doesn't that make sense? That would have been really exceptionally interesting. Okay. But we wouldn't have won a prize or anything, unfortunately. I wouldn't call it Guinness
So from the
Book of World
decimal-
Records, not the beverage company. Yes.
From the decimal point, you move it 5 over?
Yeah, so you move 1, 2, 3, 4, 5. So there'd be 4 zeros out here, right?
Only because it's e to the negative 5.
Yeah,
Okay.
because of this. That's what this means, times 10 to the, it's good old scientific notation, right? Okay. So, let's try another problem from scratch, just to really get a feel for this, and then I'll show you what the formula looks like. Yeah, you're gonna have to, okay. I understand. Do it. So, zoomed in on it. Oh yeah. Can't even, sorry. I wouldn't blame you if you're like, I need some wages, dude. Focus there. Okay, so let's say that, do I happen to know anything? No, I don't know anything. Good, let's make some shit up. Let's say that 43% of Albanians like elbow macaroni. You didn't know where I was going with that. Macaroni is not spelled like that, by the way. That is not how you spell macaroni. I have no idea how to spell macaroni right now, so I'm sorry.
That's not how you spell it?
I'm pretty sure that's not how you spell it. We'll just say pasta. Okay. You know elbow macaroni, everybody, right? If you like mac and cheese, that's what it is.
It's just
Huh? Macaroni is just macaroni. It's a special shape, elbow macaroni. Yeah, okay. All right, everybody's good. 43% of Albanians like pasta. Okay. Now, if I pick, we randomly select 51 Albanians. What is the probability that exactly? What you got, Jeff? I don't know, Jeff. Exactly 20 like pasta. You got everything you need to know. Try to set up the equation. We don't even know what it looks like in general, but we know how to set it up. Let's see, what's N, what's P, what's Q? You guys tell me that much at least to see a few people looking confused, not sure what to do. Can somebody tell me what N is? No.
51.
51. N is always the total number, right? What's P?
0.43.
Yeah, probability of success. I'm looking for liking pasta, so 43%. All right, and then somebody else tell me what's Q gonna be? What does Q have to be? If the probability of success is 43%? No.
Or the number.
Probability of success is 43%, probability of failure must be 0.57, yeah, right. P and Q have to always add up to be what? 1. Why? Because they're opposites, aren't they? Probability of success, probability of failure. So how do I set up this equation? Well, how many total people do I have? 51. And how many from there do I want to choose to do something?
20.
51 people, choose 20 to do something specific. So this seems a little repetitive, but that's kind of nice. How many successes do I have then?
20.
20, see, right? You choose 20 to be successes, so of course you got 20 successes. And then how many of these do I have? How many failures do I have?
31.
31, the rest. So you guys see that. The exponents have to add up to be the total, because that's what you're doing. You're taking a group of people and breaking them into two groups. And you're not losing anybody, right? Okay. Maybe? Let's try to throw that in your calculator. Smoke it. Let's see what happens. Whoops. Good job. All right, let's see if it comes out nice. All right. You can't see what it did. Ha ha ha. Anybody think they got the answer? What do you got?
I got
7, 9.
Yeah. Right. 0.0979, yes. So just under a 10% chance that exactly 20 Albanians will like pasta. Right? So now we finally know. That's the age-old thing that we always run into. We gotta know how many Albanians like pasta. Now we have a way. Now this by itself is pretty lame. I don't know if you guys. By itself, what the shit would I do with that information, right? This is a great question to ask. Now you probably would never ask me the question, but I'm sure that some of you guys are like, every day, Jeff, I'm like, what the shit would I do with it? This specifically is not good in this way. Can somebody pick out a specific word I keep using that's kind of minimizing the power of this thing?
Yeah.
Yes, exactly. So would it be, all right, let me ask you guys, has anyone ever been bumped off of an airplane, like your seat you were bumped from an airplane? Have you ever heard of somebody of this being bumped? Have you guys ever flown on an airplane? Let me start there.
Yeah.
Okay. Have you ever heard them come over in the announcements and say, hey, come up to us, we'll give you some money if you'll give up your seat? Is that some of you guys? I mean, it doesn't happen all the time, but
It's happened. I said no.
Good, yes, I understand. You normally wait until about the fourth announcement because it keeps going up. And then you think about it, do I need to be home or can I just take some money? Anyway, so even if you've never heard of this, why do you think that might happen? That an airline might look for volunteers to give up their seat, or they might just bump people, say, too bad. Why? Why do you think that might happen?
They sold too many seats.
Yes, why do you think they would do that?
There's a probability of someone just not showing up.
Yes! What is the best situation for an airline trying to make money? When do they want that plane to take off? What do they want to be true when that plane takes off?
It's full.
They want that plane to be freaking full of people, right? You guys kind of with me? Why? Because then every seat's paid for, they're making the maximum amount they could for that flight, and they're going to use those resources no matter if there's 10 less people or 20 less people or full. Yes?
Yeah.
So what they do then, exactly like you said, there's a chance that somebody won't show up. So they oversell. They're trying to always ride that line between getting a full plane and overselling too much that they get bad PR, right? I mean, if they had to bump 12 people, that would probably be on the news. Maybe, or there
I
might
don't
be.
know, since COVID, people would probably be like, yeah, that makes sense.
Well, now with COVID, I don't even know, I have no desire to sit my ass on a plane yet at all, for sure. But has anyone flown during COVID? Yes?
Yeah.
Did they have it where every other seat or something? Or no,
No.
they just didn't give a shit?
No,
They're like, you paid, we don't care what happens to you, we got your money, so.
The flight that I went on was like, there's been almost no people like every time that I've flown.
Alright, so some airlines,
But it depends on where you take, like, if it's like domestic flights, I
Where
think
did you
they're pretty
go?
much packing them. Oh, my girlfriend almost died, so I had to go to Europe
Oh my
to like,
God.
help her recover from the surgery.
okay, okay.
So that was
Thank
pretty
you for
fun.
letting us know, we didn't, alright. So, hopefully, everything's okay. You
Yeah,
don't have to tell me.
she's
You don't have to tell me, just hoping. Right. So that's, bring it back. So I'm glad that everything worked out. But yeah, this is why it's good. They want somebody on the airline payroll to try to work out a way to overbook to a point where they probably won't have a lot of people that could come, or else they're gonna get bad public relations, bad public image. Okay, so this kind of problem, this kind of probability would help us with that. If we have, if I knew the probability that somebody was not gonna come, the probability somebody won't show up. Right, and let's say that probably somebody won't show up is like, let's say it's 2% chance, right? I don't know what it really is. And let's say that this plane, let's say it's a relatively small plane, let's say it's got 50 seats. And let's say that they sell 52 tickets, right? So what's the probability that, what am I trying to say? That they'll have to bump somebody. So what would that mean? How do you translate that into more of a math question? The probability they have to bump someone. The probability that how many show up?
2. Well, 52 show up 2 extra, right? So
Or
2,
what?
I don't know.
The probability, they got 50 seats. So when are they gonna have to bump anybody the minute they get more than 50 people? There you go. So the probability that, this translates into the probability that they get more than 50 people. So this is not an exactly question anymore. This is a more than 50 question, but now we start to see what happens when I have more than just exactly some number. What does more than 50 mean? You basically just said it, 51 or 52, right? So if they get 51 or 52 people show up, they're gonna have to bump somebody. So what does that mean for me? That means I'll have to do a formula for each one of these and then add them up, because either 51 show up or 52 show up. That's bad. So I would just do a formula for 51, and I would do a formula for 52, and then I would add those together. So let's see. So I got 52 people, right? We sold 52 tickets. So let's look at this one first. So it'll be 52 people, choose 51 to show up. Now this is a little bit evil, Jeff. Oh, this is a little bit evil. What goes here, you gotta be a little careful. I want 51, so what I'm looking for, what's the success here? What's the success? What do these mean? 51 people that do what?
Show up.
Show up. So what is, so this is Q, because that's won't show up. So what's P? 98. So I got 0.98 to the 51st, 0.02 to the what? So I got 52 people that I've sold tickets to. So I'm gonna figure out probably that 51 show up.
So it would be 1.
Yeah, yes, 1, because I got 51 people here, so that's 1 person left for here.
Okay.
Okay. Plus 52, choose 52. So that would be all successes, no failures, right? So if I add those two probabilities up, thinking about this. I did those backwards. I don't know. Tired, Jeff. No, I think I got those right. Let me see now, I'm curious. What's this thing come out to be? Oh, I do have a calculator. So I got 52. Choose 51. So I got 51 successes. And I got 1 failure. Yeah, that's already a 37% chance. Man, my little airplane is gonna go under. Plus, so I end up with a 72% chance. Yeah, dude, kind of makes sense. It's a small airplane, yes, and I assume there's only a 2% chance somebody won't show up. So there's a really high chance that all 52 are going to show up. Right, so if you do that work, you end up with 72% chance that you're going to have to bump at least 1 person. Right? Damn. Stop. So normally, how many seats are in a plane? Normal size plane go across the states.
100, I don't know.
Under 200 something, yeah. Okay. All right, so let me give you this. Let's see what time it is. Oh, we're good. Okay. Let's see. Oh, that's right. We got to do one more thing before I do this. Let's see if I have store to do. No, I can't use that. Bum, bum, bum. I just want to try to stay up here on the overhead so I'm not shifting so much. Just need paper. I got 1 piece of paper. Okay, that'll work. All right. So here's the formula for this. What was 51 in this? Well, let's see. Let me do the problem I just did. Here we go. What was 52 in this problem?
The amount of seats. No, the amount of tickets sold.
True. So maybe I should do this Albanian one. Okay. Back here at this Albanian pasta one. 51 was N, right? The total number. Right?
Yeah.
Okay. So the probability of this many successes, we're going to kind of go back and figure out what the formula must be. So I have n things, and I want to choose this many successes. So my variable in this kind of problem is the number of successes. So if I have 51 things, how many successes could I have from what to what? If I have 51 people, how many of them could be a success?
51.
Or, so from what to what?
0.
Good. People always forget about 0. From 0 up to 51 could be successes, right? They could all be horrible failures, or they could all be successes. I like it. So n, choose some specific number. It could have been 20 or 21 or whatever I wanted, right? So that's the variable. And then this was p to the x, because I want this many successes. Now here's where things get a little weird. Where the shit did 31 come from for that one?
N minus x.
Okay, well maybe it's not so weird. 31 was because we did 51 minus 20 to get 31, which is n minus x. So in the formula, it might look a little strange to some of us, but that exponent is just capturing what's left, right? That is the official formula, and I haven't even told you the name of this kind of problem yet. Every problem we've done like this so far, they've all had two possible outcomes, yes? A success and a failure. So we call it a binomial probability because we are not creative as a group, mathematicians. So we have two outcomes possible. So this is a binomial probability equation here. So that's another one to add to the old list. Now, one more thing. I don't even know if you guys know any. I used to always pick on Shaquille O'Neal because I like to talk about the probability somebody makes a free throw. Do you guys even know who Shaquille O'Neal is anymore? Yes, some of you. He sort of still does things, okay. I know he was a Celtic at one point in his career, but I normally remember him as a, well, he started off on the Magic, and then he was a Laker, so basically I don't like him, because he was on the wrong team. But then he was on the Celtics, I'll get over it. So, let's pretend, let's say that Shaq makes, let's be really nice, 30% of his free throws. If he takes 20 free throws, how many should he make? How many would you expect him to make? So this is an expected value. So another way to say that is, how many on average would he make if he took 20 free throws? What do you guys think? Yeah, he makes 30% of all of his free throws. So any group of 20, I would expect him to make 30% of 20, which is 6. Now, does that mean he's always going to make exactly 6? No. But on average, right? So if he suddenly has a streak of 11, I'm like, you got a bad streak coming, right? Could be, if he maintains the same percentage. So what did we just do? You did 30% of 20. Let me kind of turn this around a bit. You did n times p. So, and that is the formula for the average. Now, I really want that to make sense. That is the average amount you would make. Right? So any binomial situation, if I know the percentage, so what's the average number of left-handed people out of 15, it would be 11% of 15. It would be n times p. Does that make sense? And I want you to understand. Two things. I'm really tired today, so I'm sorry. I didn't really set this up as well as I wanted to. Whenever we're presented, I'm pretty sure I said this before, whenever we're presented with a new way to see data, so remember the whole x, p of x?
Yeah.
That was a new way to list data. And I try to make a big deal out of, we want to find the mean and the standard deviation, because they're the two most important pieces of data I can get, the two most important summarizations I can make. Here we have a binomial probability distribution. I want to find the mean and the standard deviation. Compare this formula to almost any other formula we've ever had. Isn't this one the best yet? Is there any summation symbol? Do I have to make a table to do it? No, it's just freaking n times p. That's the best. All right, so let's all cross our fingers for the standard deviation formula, right? Now this one would take a little more math than most of us have to explain, but it comes out to be this. Square root should be kind of expected. What's not total expected is that it's n times p times q. Right? So let's do this. For Shaquille, taking his 20 free throws, the mean was 0.3 times 20. The mean is 6. Don't say anything yet. Can you figure out what the standard deviation would be for that situation? Don't say anything. Try to figure out the standard deviation. So it's n 20 times p 0.3. And what's q?
6.
No.
Okay.
If p is 30%, 0.3, q
Oh.
has to be
0.7.
0.7. I like, you always have to make one. So please realize, make a note for yourself, p and q are probabilities. They have to be at most 1. They can't be more than 1. It's a real easy way to make some mistakes.
Do they have to equal exactly 1?
It depends on if you calculated it from a sample, and so you might have rounded. But normally if they're given to us, we find q by subtracting 1 minus p, so we sort of artificially make it. Yeah.
So these are the formulas for finding the mean and standard deviation.
For a binomial probability situation.
So that's, okay.
So how do I know when I'm in a binomial probability situation? They give me a probability of success. They ask me a question like, what's the probability we get 7 successes or something, right? So there's a little p, we can find a little q. There's an n, total number. There's, I want this many successes out of that, right? So it's gotta have that kind of feel to it. And then I know that this is the formula to figure out the average and the standard deviation. So let's see. So on average, he makes 6 free throws. And what's the spread? It's like 2.049.
0.49.
All right, the last thing for today. Well, that's a good phrase. All right, I think I might get you guys to wake up a little more now. Last thing for today. How long is it going to take? All right. Sorry. I don't think this has come up yet, but let's make this official. Let's make this official. Can somebody remind me, in a normal curve, I know within one step there was 68%. You guys remember that?
Uh-huh.
That's how many was familiar. Can somebody remind me within 2 steps? Anybody remember? There's a big old chunk of it.
90.
95. So, let me get your opinion about something. I really want this to make sense. A lot of things are close to normal. So, in general, would it be unusual for something to happen out here? What do you think?
Yeah.
What is the probability that something happens out there? If there's 95% of things in here, what percent is out here?
2.5. side.
So a total of 5%. If something had a 5% chance of happening and it happened, would you consider that unusual? What's your gut tell you?
Yeah.
I mean, somebody's like, there's a 5% chance he's going to make that shot. Holy shit. I mean, that would, right? You go, how the hell, what? Yes, maybe, right? Like somebody's like, all right, I'm going to hit this and I'm going to make that, I'm going to win that game on that pool table about 3 tables over. You ready? Oh, and you're like, no, what the shit? So it's just really unusual. Doesn't that jive with just what we think? Wouldn't that be unusual? We would call that unusual because if it was less than 5% chance of happening, of course we're going to call that unusual. So thankfully, that's exactly what we say. Anything that is more than 2 steps away from the mean is unusual, officially considered unusual. So, what does that mean about Shaq? How many free throws would he have to make for it to be unusual? What do? He should be really primed for this. So instead of just taking 1 step up and down, you're going to take 2. And each step is 2.049. The mean, though, is what? Careful. 6. So if I go 2 steps up, where do I end up?
At 10.9.
0.98.
Oh, yep, there we go. I was gonna say that.
I got you. Let me stop for a minute. You guys see that? Is that all right? Does it all come together? I mean, 2 steps away is pretty far away considering 1 step is the average distance to all the data points. So 2 steps out, that makes sense that it's pretty damn far out there. Anything more than that, so it's just like the average height for men is 5'9". If I go 1, 2 steps up, anybody out here, tall as shit. Anybody out here, short, yes? Short enough to make you do a double take, right? Or tall enough to make you do a double take, right? If you saw somebody kind of tall, you're like, hey, if you saw somebody 7'7", you're gonna go, what, wait, right, yes? Not because you're inconsiderate, it's because we're human, and we don't see somebody that tall all the time, yes? Okay. All right. So what's this one down here then, sorry? Anybody do that one?
Yeah.
Is that right? Part of my brain is awake, I guess. So if Shaquille made 12 free throws out of 20, assuming that what I've said about him is true, which is probably kind of mean, but I won't. It's probably higher than 30%. But if he did, given these conditions, would that be unusual? Yes, it would be, right? Or if he made 1 free throw, that would be unusually low. 12 would be unusually high. Would 7 be unusual?
No.
Hell no. It's right in the middle of what's usual. I like it. Okay, so let me give you this. We're not going to do this today. Because if I did, I would have to accept you slapping me in the face. As I said, that was the last thing we're going to do. But I just want to give this to you. Whoa, that's nice. There's one more in there for Sebastian. So we'll do this next time, but you have this to look at for now. Here we go. Here. Here. Oh. Did you go? All right. Please don't forget your IDs.
I did end up getting cleared over the weekend for the things I'm missing.
Yeah.
To catch up on what I don't understand, so.
Okay. All right. Good. Good.